Hello guys, hope you're doing well. My name is Mahmoud Kiosari and welcome to the new chapter of Advanced Algebra. As you guys remember, for the last chapter we were talking about the complex numbers. Why we have the reason of that invention, which is not going to be funny obviously. We need that, and what were the ways that we could simplify the thing, we could add them up, we could multiply them, or any kind of related thing. So at this point I thought it would be better to have one step back and talk a little bit about the examples, about the complex numbers, some kind of questions for you guys to solidify all of your knowledge related to that. Without further ado, let's talk about it. So again, the complex numbers, the practice and mastery guide. At this point, we are going to test your skills in order to make sure you guys completely understand it. So grab your pen and paper and make sure that you're going to do that alongside me. But just in case, before seeing any of this question, after seeing this question, try to just pause the video, do it by yourself, think about it, and then try to look at the answer itself. Cool? Let's talk about this one. So the section 1, as you guys remember, we were talking about the I itself, and sometimes the I comes with a power. Again, what was I? I was a number that means the square root of -1. It means that that guy actually doesn't exist, but we are going to give that meaning in order to use it in our day-to-day some kind of work which is related to math itself. And I told you that I to the power 2 is going to be -1, I to the power 3 is going to be -I, and I to the power 4 is going to be 1 itself. And just in case, if you do have any power rather than just 1, 2, 3, or 4, the only thing that you have to do, just divide n by 4 itself. Whatever your quotient is, just get rid of that, and the only thing that you have to take care of is your remainder. Whatever the number is, try to compare it with one of these 4 conditions, and finally you have your final answer. So let's look at it, what would happen over here. So I to the power 3 is one of the conditions, so it's going to be -I. We already know that. I to the power 6 divided by 4 is going to be 1 multiplied by 4 plus 2, right? So 2 is the remainder. So if you don't have 2 as a remainder, the only thing that you have to do is know the fact that I to the power 2 is -1, so keep it. What about I to the power 12? Again, do the same thing. 12 divided by 4 is equals 3 times 4 plus 0. So since we don't have some kind of remainder, we're going to work at what? We're going to focus at the final section, which is I to the power 4, which is going to be 1 itself. And finally, I to the power 39. So 39 divided by 4 is going to be 4 times 9 plus 3. So we are going to have the 3 as our remainder. I to the power 3 is -I, and this is the answer. Simple as that. So we do have a challenging question. I to the power -1. If you guys remember, any term or any number to the power -1 means that we have to find the reciprocal of that. So I to the power -1 is 1 divided by I. And if you guys remember, the way that we can get rid of somehow complex numbers in the denominator was we can multiply the both sides or the numerator and denominator by the conjugate of our specific value, or the conjugate of the complex number over here. And what was the conjugate? The conjugate was a number that the only thing that you have to do, make the imaginary part negative. So let's multiply that. -I itself. What do we have? We do have -I divided by -I squared. So what is I squared? I squared is -1, right? -1 times -1 is going to give you 1 itself, and the final answer is -I. Simple as that. So let's see, some kind of the question actually is going to cause the fact that we need complex numbers or imaginary numbers. So as you guys know, this answer, or finding the solution for this question, is not defined in our previous knowledge, but as we know, after finding out about the complex numbers or imaginary numbers, we can do that. So if you do something like this, that x is equals to root of -9, you do have something like this one. And we all know from a fact that root of a times b equals root a times root b. Is that the case? Would it be okay if I write it down as root of -1 multiplied by root 9? Why I'm trying to do that? Because I'm trying to separate the real number and imaginary number, right? But still they're side by side, so we have to consider that. Root of -1 is going to be I. Root of 9 is going to be 3, so we do have it at 3i. Simple as that. What about this case? Still, if you rearrange it, you have x to the power 2 is -49. So it means that your x equals to root of -49, and the only thing you have to do is just write it down as -49 equals to root of -1 times root of 49. This guy is 7, so the final answer is 7i itself. What about this case? The only thing you have to do at the very beginning is just get rid of that 2. How we can do that? Divide both sides by 2, right? We know it. from our basic algebra. So it means that you, at this point, let me just write it down with another color, your x2 is going to be negative 25. Still the same. Root of negative 25 is equal to root of negative 1 multiplied by root of 25. This guy is going to be 5. You have them side by side, it would be 5i itself. And this guy is our very famous formula, or very famous equation that causes some kind of aspect that we do have about the complex number, and the final answer is what? Root of negative 1, which is going to be I itself. As simple as that. So let's move on to the next part. It means that right now we do have the answer, and we would like to check that everything is okay or not. As we just saw over here, we had I to the power 3 as negative I to the power 6 as negative 1, I to the power 12 as 1, I to the power 39 as negative I itself. The challenge was this one, so we solved it, and in the meantime we found all of our answer itself. One thing that maybe some of you noticed is that x is positive and negative 3i. Why is that? Because as we know, if we do have 3i as the answer, if you multiply 3i by itself, you're going to have what? You're going to have the negative 9. In the meantime, if you have negative 3i multiplied by negative 3i, you're still going to have that. Why? Because negative times negative is positive. 9 squared is still going to have negative 9. That's why we do have this positive negative for both of them. So be careful about that. Maybe it's going to be a little bit challenging right now to completely digest the fact that you have positive and negative, but in the future you will completely understand. Let's look at this guy. Let's look at this question and try to have the components and some kind of basic arithmetic. So when we do have complex numbers and you would like to add them or subtract them, the one thing that we know is that the similar terms, and by similar terms means that real and imaginary can be added up or can be subtracted by each other. You cannot add some kind of complex number or imaginary number by another real number. So be careful about that. At this point, we are going to see a couple of questions. The very first one is that for each number, we are going to identify A and B. So this is not that hard. It means that my A is going to be a real number and B is the number beside imaginary is going to be 3. My A is going to be negative 2 and B is going to be negative 7. And also my A over here is going to be 0 because I don't have any real number, and my imaginary one is going to be 14. And this point I only have real, so it's going to be negative 9. On another hand, we are going to do the simplification. As I just told you, we are going to consider real numbers together, add them up or subtract them, and we are going to do the same thing for imaginary number. So it's going to be 4 plus 3 is going to be 7, and 2i subtracted by 5i is going to be negative 3i. So we have to do this thing for another side, but make sure you are going to apply or imply this negative number inside the parentheses to get rid of that. Negative 1 times 2, negative 1 times negative I, right? So if we can rewrite this guy down as negative 5 plus 3y subtracted by 2 plus I itself. By this way, we are just getting rid of parentheses. So negative 5 plus negative 2 is going to be negative 7 plus 4y is going to be your final answer. So what would happen over here? We don't have any imaginary part, okay? We're going to keep the real and real. Imaginary just by itself. So this one is going to be 2y subtracted by 2. We have to do the same concept that we did over here over this question. So if you do that, we go to 6 subtracted by y, I, subtracted by 6 subtracted by I. So what would happen over here? At this point, 6 and 6 are going to cancel each other. You have negative 2y itself, as simple as that. As we can see, we do have the final answer over here. So what is the key inside? The rule is simple. Again, we are going to combine like terms. What are the like terms? It's going to be real parts. We know it as A1, A2, A3, whatever, and with other real parts. And the imaginary parts, B, with other imaginary parts. And the structure finally, again, should be a complex numbers that is going to be have just as the way that as an algebraic binomial means that I do have two section itself. Simple as that. So let's talk about basic multiplication. What did we have? The basic multiplication means that right now I do have my coefficients, but my coefficients is not normal anymore. My coefficients is an imaginary number. What I have to do, I have to multiply the whole thing by the first term, multiply the whole thing by the second term. So what do we have? 5i times 3. 3 and 5 can be multiplied by each other, but I should be there just as the way it is. So we do have 15i subtracted by what? 5 times 2 is going to be 10. I times I is going to be 10i squared. So at this one, you can simplify it more. Why? Because I squared is negative 1. So if you apply this negative 1 times negative 10, it's going to be positive 10. So you have 15i plus 10 or 10 plus 15i. It doesn't matter again. So what would happen over here? I do have it as negative 2y times 4 is going to be negative 8i. I do have negative 2i times I itself, so negative 2i squared. Still, I squared can be simplified as I2 is equals negative 1. Negative 1 times negative 2 is going to be positive 2. So finally, you have 2 subtracted by 8i. Simple as that. Same thing is happening over here, but at this point, I don't have some kind of real number. So the only thing you have to do is just negative 3i squared. I squared is going to be negative 1. So finally, you have 3 as your final answer itself. So what would happen if we do have multiplication of some kind of complex number by another complex number? As we all know, the only thing that you have to do is just multiply by the first term by first term by second term by first term, second term by second term. If you do that, what would you have? You have 4 times 2, 8, subtracted by 20i, then plus 6i, then we do have negative 15i squared. Is that the case? Simplify it more? Yes, I can. First, I do have I squared, so I can have it as positive 15. Then I do have negative 20i plus 6i. I'm going to have it as negative 14i. I do have 8. These two guys can be simplified. So finally, I do have what? 23 subtracted by 14i itself. I believe you can do these two. It's not that kind of hard. You can just answer these on the comment down below. But just in case, if you couldn't handle that, we do have our answer over here. As you can see, for the first one, we do have 23 subtracted by 14i. For the second one, we have 13. And for finally, we have negative 2i. The only thing you have to do is just pause the video, try to find the solution based on your way. Most of the time, there's a very common way between all of those answers. And then compare them. If you have any problem, just comment me down below. So again, a very important part is about the sign flip. A common slip up is that you are going to forget I squared is actually negative 1. I saw it millions of times, so please be careful. When you multiply the last terms, especially in FOILs, 3y times negative 5i. So the very common mistake is that when you have your final thought or when you have your final multiplication, you just leave it as the way it is and say that, oh, this is I squared. I cannot do anything more. But the story is another thing. Why? Because I squared is actually negative 1 or itself is a real number. That's why you have to consider that. So be careful about the sign itself. So what about the conjugate and its purposes? As we just told you, the conjugate that is going to be used in order to have a reflect over the real axis. As you know, we had it before that instead of just talking about the normal plane, we are going to talk about the complex plane, that we do have this guy as real. We do have this guy as imaginary, right? We are going to find a conjugate. Conjugate means that whatever number that you have to find its reflex while you consider the real plane or real axis as your mirror. So this guy is your conjugate. So the only thing that is going to happen for your conjugate is that real number is going to be the same, but imaginary is going to times by negative itself. For instance, if you do have this kind of numbers as your complex numbers, the only thing you have to do to find a conjugate is just convert this one to negative, convert this guy to positive. And this guy is just by itself. Y we have to consider to negative, and z or equals to 8 is just going to, his conjugate is going to be itself. Why? Because z equal to 8 is going to be at this point. So if the point is already on the mirror itself, actually you don't have any reflect. The reflect is going to be itself. So the conjugate product, and the thing that we are going to do is just multiply one number by its conjugate. If you guys remember, we had a formula for that. What was it? A plus IB times a minus ib, difference of perfect squares, is going to be a to the power 2 plus b to the power 2. Either you can multiply 3 plus 4i times 3 minus 4i and find an answer, or you can use this formula. So if we do that, it would be so simple. A to the power 2, 9 plus 16, 25. First one. Second one is going to be 1 plus negative 2 to the power 2 is going to be 5. Third one is going to be negative 5 to the power 2 plus 1 is going to be 26. Simple as that. So at this point, you see that we do have our answer itself. So this is everything you need to know about some kind of conjugate, that we are going to use that most of the time in order to get rid of the number with the complex number that we do have in denominator, but we also can use it for this kind of case or for this kind of questions. Then we have this arithmetic, which is going to be about division. If you guys remember, we need to find a way in order to get rid of this denominator, because first of all, we don't write the fraction, especially if you do have the radical, if you do have complex numbers on the denominator itself. So we have to find a way in order to get rid of that. What is that way? Just multiply both sides, or the numerator and denominator, by what? By this conjugate itself. 3 minus 4i, 3 minus 4i. Do the same thing with negative 1 plus 2. The only thing you have to do right now, just find this multiplication, You already know this multiplication. It's going to be a to the power 2 plus b to the power 2. 9 plus 16 is going to be 25 as your denominator. What would happen over here? Negative 1 2 plus negative 2 to the power 2 is going to be 5. Simple. The only thing you have to do, find these numerator, and you have the final answer, which we do have it over here. And you see that our final answer for the first one is going to be this, and the second one is going to be this. The key inside over here, and our goal of division, is to remove from the denominator. We are going to achieve this by multiplying the fraction by a clever form of our some kind of I itself, the conjugate of the denominator over itself. It's going to transform your denominator into a real number, and it's going to allow you to write down result in a standard form a plus by, because right now you cannot do that if you do have the division. But if you do that one, if you find the conjugate and multiply by that, you have everything that you need. So another thing that we had was about the visualizing, about the complex plane. As I just told you, for the visualization, instead of just normal x-axis and y-axis, we do have real number an imaginary number, and the only thing you have to do is just imply this guy over here. For instance, 4 plus 2i is going to be what? 4 step to the right and 2 step to the top. So this is going to be your value, and this is going to be the vector itself. What about this one? Same. And after that, we had the definition about the modulus of specific some kind of complex number that we know it as absolute of z. I told you absolute of z based on the Pythagorean theorem is going to be hypotenuse. Is that so? So it means that in order to find that, your z is going to be root of a to the power 2 plus b to the power 2. Without any respect to the sign itself, the only thing you have to do is consider the absolute number of a and b over here. So we had the z over here is going to be a to the power 2 plus b to the power 2 is going to be root of 25, that we do have it as 5 itself, and same thing over here. So let's see some answers. As I just told you about the plane one, instead of x-axis and y-axis, we do have real and we do have imaginary axis. By considering the number like 4 and 2, like 3 and negative 1 and negative 4, actually, yes, negative 1 and negative 4, and then we do have a negative 3 and 5, you can simply find everything that you need. On the other hand, we are looking for the modulus of z, that we do have it as 4 plus 3y. We have to find the root of 4 to the power 2 plus 3 to the power 2. Do the same for this one, and finally you have your answers you need. So again, the modulus of the complex number is its distance from the origin. What was origin? Origin means that 0 is going to be our origin itself on the complex plane. The formula a plus by, or absolute of a plus by, is going to be root of a to the power 2 plus b to the power 2. This one is going to be simply the Pythagorean theorem. As we know, c is going to root of a to the power 2 plus d to the power 2, that a and b are going to be real number, and that's it. Another thing that we do had was about leap to polar form. It means that instead of just having the complex number, I would like to find the modulus, and I would like to angle that my some kind of complex vector is going to have the positive side of real axis, right? So the very first thing that we saw was that at the first point, we have to know at which quadrant are we in. It's going to be quadrant number 2, 3, or 4. How we can find that? Again, it is simple. The only thing you have to do is just draw it, right? So z is equals 1 plus y. It means that at this point, we'll know for a fact that this is real part, this is imaginary. So at this point, what you got? At this point, you have, let me just use another color for you. So at this point, you for a fact that it's going to be over here. So vector number 1. What about the second one? Root 3 plus y. Still is going to be something over here. It's going to be quadrant number 1. Negative 4 plus 4i is going to be negative 4 over here. 4i is going to over here. So you have it at quadrant number 2. What about the final one? Is going to be 5, and it's going to be negative 5 root 3. Whatever is that is going to be root number 4. And at this point, we are going to see that how we can convert it to the polar form. If you guys remember, for converting to polar form, we need two things. The modulus is going to root a to the power 2 plus b to the power 2, and then we need an angle. It's going to be tan inverse of some kind of imaginary number over real number. But the first thing that you have to make sure is that not all the time your tan inverse is going to be final answer. Why? Because first of all, you have to find at which quadrant you're in, and based on the thing that I told you previously, you can find your final answer itself. So another thing that we learned was about how we can convert it back from polar form to a normal complex form. The only thing you have to do is you have your r and you have your angle. Then for a is going to be r cosine of theta, and your b is going to be r sine of theta. I somehow proved it to you in the previous video, so you either can memorize it or you can use it intuitively. So let's talk about it. Let's talk about the section number 1 that we had a question, because at this point I asked to find the arguments in degrees for each of those numbers. Again, the only thing, the very first step is that we have to understand at which quadrant we are in. Why? Because then we are going to find an angle. As I told you, try to find the angle while you see, or you can convert all of those numbers a and b to their absolute value. By doing this way, you can find something that we call it as reference angle. Reference angle is going to help you find your final angle. And what is the reference angle? The reference angle is the smallest angle that your vector can make with x-axis. So on that point, you do have the reference angle, you can find the actual angle. So let's look at the question number 1. We had it z was equals 1 plus I. So obviously it's going to be tan inverse of 1 over 1. Both of them were positive, so at this point you have 45 degrees. Your reference angle and actual angle are going to be the same. What about the second part? The second one is the same because both of them are positive, so your fact that your reference angle and actual angle are going to be the same. What about the third one? The third one, we know that this guy is going to be what? Is going to be somehow over here. So if you just use this way, the angle that you're going to find is going to be this section. This is your reference angle. But in the meantime, we are looking for actual angle, the angle that your vector is going to make with positive side of real complex plane. So at this point, what you should do, you have to subtract your reference angle from what? From 180, the thing that we actually did it over here. So it's going to be 135. Finally, for the final part, you do have this one, right? So your fact that is going to be in some kind of the number 4, we are going to be in quadrant number 4, right? So your fact that either your final angle is going to be negative of reference angle, or in order to find that, you can subtract your angle that you just found from 360 and you have this guy. Simple as that. So what about the second part? We are going to reach from this guy to this one. Again, same. Either you can write down your polar form as this form, or sometimes that in some textbook we do have it as r, e, or Euler times to the power I times theta itself. For instance, at this point you have your r as root 2, you have your angle as 45. You can write it down 2 e to the power of, root 2 times e to the power I times 45 degrees. Or you can write it down like this. It doesn't matter. Again, the first thing you have to know about this one is in which quadrant is that. If you draw it, it would be in the second quadrant. So obviously, after you found your reference angle, then you have to do subtract it by 180 and you have your 135. So the very important and the thing that I'm going to very emphasize on that is that you have to trust the quadrant, not just calculator. Why? Because if you just use your calculator blindly, either it's going to give you a positive angle or negative angle. But right now you're not sure in this angle in which quadrant it is. For instance, if you do have a case that your vector is in the third quadrant, obviously angle should be more than 180. But if you use it in your calculator without considering the fact that you have to make both of them as positive, you're going to have a positive angle. So this is not going to lead you to the thing that you want, right? Because right now the angle that you found is going to show that your vector is in the first quadrant, while the real-time scenario is going to be third quadrant. So be careful about that. And after that, that was the final part. That was the final section that we have related to this part. So again, try to pause the video for any of these questions and try to completely understand it. First, try to do it by yourself, and then try to some kind of use the answer sheet that I just gave you. Again, if you had any problem, if you had any solution, please comment me down below. I would be more than happy to help you. That's my passion. Thank you guys for watching this video with me and being here with me. Have yourself a great day, night, whatever. See you around.